Hello friends, welcome to yet another session of fault finding and diagnosis of Godrej appliances. Today we would be looking at a fault of water leakage and sprinkling from the indoor unit of an air conditioner. The customer complaint would be there is a water leakage from the air conditioner but the cooling is okay. The water starts leaking immediately after starting, or the water leakage starts after 2 to 3 hours of the air conditioner running. There is also some complaint that water is sprinkling from the air conditioner or water is dripping from the grill or the lower. The questions to be asked to customer is, when did you get the air conditioner installed or reinstalled? To get the exact clarification about whether this is related to any installation related complaints. The second question that we can ask to the customer is, what is the location of the leakage? Left side, right side, from blower or from the middle or from the back of the air conditioner indoor unit? Where exactly is the water leaking from? The answer to this question will give us a clarity about the exact nature of the problem or the exact nature of the leakage or the area from where the leakage is happening. Then we would ask the customers, have you cleaned the filters? That is, have you done regular preventive maintenance of this air conditioner, like cleaning of the filters or cleaning of the grills, etc. This is to understand the requirement of preventive maintenance service of the air conditioner, whether it is not done. So we'll ask them, is there any seal system repairs done recently? If there are any seal system repairs done recently and the repair has not been done to full satisfaction, then there is a chance that there may be less gas or excess gas in the system, which may lead to sometimes excess cooling or ice formation, or maybe due to less cooling. These defects can also cause water leakage. Then we'll ask the customer, is there any service done recently? To know whether any preventive maintenance service is done recently or if any other service is done and the preventive maintenance service is due for the air conditioner. Then the last question that we can ask the customer is the water leakage continuous and it is prolonging for a long time, or whether it starts and stops periodically? The answer to this question will give you a hint about whether the drain is choked up or drain is partially choked up or it is incapable of completely draining off the condensate water. So there are some inferences that we can draw from whatever questions that we have asked the customers, and we make a dog matrix of the possible defects for this symptoms. That is, there is a wrong installation of drain pipe, wet or dry service was not done, filter or the coil is blocked, there is an uneven wall surface on which the indoor unit is installed, which leads to wrong gradient, and that's why there is a leakage from the drain. There can be a partial gas leak which would lead to ice formation, and that ice condenses and it leaves water traces all over the indoor unit. Then there could be a damaged or improper insulation of copper pipe. The copper pipes which carry the refrigerant from the indoor and outdoor unit, whether they are properly insulated or not, or if they are not insulated, then there is a chance that the condensation water from the cold copper pipes will trickle down somewhere in the indoor unit and it will leak outside the unit. There is a damage to the insulation of the drain tray. There is a blockage of drain tray. There are cracks in the drain tray. There are some external factors like some rat bites to the drain pipes or tubes. There could be some compressor mechanical defects also. Poor pumping of the compressor could be one of the reasons, which can eventually lead to water leakage from the indoor unit in some rare cases. So we put them under mechanical, usage, environment conditions and other conditions. Now we start checking each and every of these possible defects one by one. The first check that we do for every symptom is to check the main power input source to the appliance, whether the neutral is to the left, the phase is to the right, we have a proper earthing, and the phase neutral and phase earth voltages are somewhere near to 230 volts, and there is no voltage between the neutral and the earth pin. These are the standard checkpoints that we check whenever we start diagnosis of any appliance. We also check the wires, whether there is a continuity or discontinuity, or whether there is a loose contact inside the wires, or whether there is a shorting of the phase and neutral wire or phase or ground wire. Now we come to improper installation of the drain pipe. A maximum problems of drain blockages are caused because of wrong installation or improper installation of the indoor unit. During the installation of the indoor unit, you see 1, 2, 3, 4, and 5. Diagrams over here. The first diagram to your left is showing the right way of installing the drain pipe. That is, the drain pipe should have a slope or a gradient outwards from the indoor unit, and it should come down, and the opening of the drain pipe below, it should not be inserted, or it should not be blocked by any gutter, or it should not be blocked by another pipe, or it should not be inserted in any gutter or inserted in another pipe. It should be in the open. This is the ideal condition, or this is the ideal installation of the drain pipe. There are four other conditions given which are causes of wrong installation. The drain pipe has got an upward bend outside of the installation room. So this upward bend will cause blockage of water to easily drain from the drain pipe to the outside. And when this water flow is blocked, that water will accumulate inside the drain tray, and it will in fact leak from inside the indoor unit. It can leak from anywhere from inside the indoor unit. Then the third diagram shows that the drain pipe is properly installed, it is given a good slope, but the mouth of the drain pipe is inserted in a gutter where there is water. What this does is, this creates an airlock in the pipe. When there is an airlock in the pipe, that air pressure will prevent any drain or condensate water from entering this pipe, and all the water will be accumulated inside the indoor unit itself, and when the drain tray is full, it will leak from various parts of the indoor unit. The fourth condition is similar to the third condition, that the drain pipe is in a drain ditch. It is extended inside the drain ditch. It will give a similar problem of the improper the air lock inside the drain pipe, and it will give a improper water flow. Then the last diagram shown over here has got a U bend at the bottom of the drain pipe, and this U bend or waviness will hold some water, and it will not allow the entire water to flow out. What this water column does is, it blocks or entraps some air inside the drain pipe, and that entrapped air will cause a back pressure to the drain, condensate drain, and that water will not be allowed to pass through this pipe, and it will accumulate inside the indoor unit, and it will leak from somewhere in the indoor unit. These are the various different types of drain blocks. Whenever there is a drain line which extends from inside the room through an opening in the wall to outside the room, there should not be a condition where water is trapped anywhere in the drain pipe. The drain pipe gradient or its slope should be such that the water flows to the drain pipe, but nowhere in the drain pipe is it enclosed or entrapped, or it is stagnant, or it is not moving. It should not be in such a condition that the water is not moving anywhere inside the pipe. Such kind of a stagnant water will cause air blockages and air locks, which will prevent further drain from passing through the drain pipe. These are the wrong and right conditions of installation of a drain pipe. When we use a PVC pipe for extension of the drain, we give it a slope of 1 centimeter after every 1 meter of distance of the drain pipe for faster delivery of condensate water. This is the minimum slope or gradient which we should give to any drain pipe outside the enclosure. When we bunch the suction line, the discharge line, the drain pipe, and the 3-core or the 4-core wire, electrical wire, as the case may be, from indoor to outdoor unit. When these pipes and the electrical cord, when they pass from indoor to outdoor unit, the drain pipe should be the bottommost part of this bunch, and this should be the cross section. This should be whatever is shown in this picture. That should be the actual cross section of the bunch. The drain pipe at the bottom, the suction line and the discharge line at almost the same level, and on top of these two pipes we will lay the electrical wire. Now the drain pipe is given at the bottom so that by gravity the water can easily enter the drain pipe and it can easily move from indoor unit to outside the room or outside the enclosure, and it can drain outside easily. And when we place the drain pipe at the bottom like this, and while taping all these things together, we should be careful that the drain pipe is not pinched. We don't tape it so hard or so rigidly or so tightly that the drain pipe is partially pinched or blocked somewhere. That is an aspect which we should take care of. Another defect is that wet service or dry service is not done on the air conditioner indoor unit. When the indoor unit coil is loaded with dirt or dust or any kind of fungal growth, what this does is it entraps the condensation water on the coil, and that water is not allowed to trickle down the fins and go to the drain tray. These water droplets, they get entrapped and loaded onto this dirt, and when the dirt can hold no more water, what it does is the water droplets then start dripping from this dirt directly onto the blower, and when the blower runs, the blower impeller will take this water and it will throw it out through the grill into the room. So this dirty water is thrown out by the impeller into the room only because that water is not trickled down the fins to the drain tray, and it is dropping onto the running blower. So to avoid this kind of a condition, we should ensure that the indoor unit coil is thoroughly cleaned with a jet of water through a jet spraying unit. Mechanical jet spray unit should be used for cleaning the indoor unit. That action is called as a wet service or a jet service. That service should be regularly done and they should not be delayed beyond a certain point. Otherwise, a clogged filter will always give rise to water leakages inside the indoor unit. There are some YouTube links to the indoor unit dry service and wet service videos. You can have a look at the videos and see how it is properly done. They are very good. They are explained in a very good manner. And the next defect could be there is an uneven wall surface. That wall surface has got a lot of bumps, it has got a lot of projections, and that wall surface is not even. Due to which, when we install the indoor unit inside that surface, on that surface, there is a chance that that indoor unit may get skewed or it may get tilted some places. due to which the drain tray is not in a proper alignment or in a proper gradient, and that will give rise to water not following the destined path, the not following the path which is designed for it to go out of the indoor system, and it follows some other path, and it can trickle down from any part of the body of the indoor unit through to which it comes in contact with. So we have to check for uneven surfaces of installation also. This can also be a cause of water leakages from the indoor unit. If there is an uneven surface, you should please ask the customers to get it rectified and reinstall the indoor unit of the air conditioner after that uneven surface is rectified. The next defect would be a partial gas leak. To check for this defect, what we have to do is we have to check the back pressure or the suction pressure of the air conditioner when it is running. If it is less than normal, it will indicate that there is some amount of gas leak in the seal system. Maybe the gas is not completely leaked out, but there is a partial gas leak. The partial gas leak will decrease the suction pressure, and it would in fact it will result in a lot of ice formation in the indoor unit. This ice eventually will form and it will condense, it will melt into water droplets, and there will be water droplets all over the coil, which will not follow the proper route of condensed water, and it will leak, and it will drop on the blower, it will drop on the grill, it can drop anywhere. So less gas condition can also lead to water leakages from the indoor unit. Here what we have to do is we have to first locate the leakages, locate the leak from the seal system. We have to mend, or we have to brace, or we have to plug that leakage, and then we have to vacuum the system. We have to refill the gas by weight method only. For this process, you would be requiring the tools which are shown in this diagram: manifold gauge, digital clamp meter, digital temperature meter, electronic leak detectors. We need refrigerants. We need a good vacuum pump, two-stage, and at least 5 CFM for air conditioners. Less than 5 CFM two-stage air conditioners is not a good or healthy vacuum for air conditioning units. Then the best meter to check vacuum is the micron meter. Then we would be requiring charging hoses for different pressures of air conditioning refrigerants. There are different charging hoses. Then we need a weigh balance unit, weighing scale, so that we know exactly the amount of refrigerant that we are dosing into the system. We need a single gauge. We need a nitrogen cylinder for flushing. We need a nitrogen cylinder also to fill in nitrogen to up to a certain pressure, so that we can check for leaks, and we can check the holding pressure. We need a soap and sponge unit, so that through the bubble system we can check for leaks. The different pressures, the different suction pressures for different refrigerants in our Godrej air conditioners are given in this table. You can refer to this table for the suction pressures, and you can check for the respective refrigerants that the air conditioner is holding. We have to check it at the suction line. The suction pressure has to be checked at the suction line. There is a cap on the suction line, the brass cap. We have to remove the brass cap, and we have to insert this. There is a Schroeder valve inside, so we have to insert the gauge, and we can check the pressure from the gauge while the unit is running. This has to be checked when the unit is running, not when the unit is idle. When the unit is idle, we have to check the standing pressure, which is the last column in this table. Check for the possible location of the leaks. To identify the leaks, one easy visual method is to check for oily or blackened spots at every joint of the refrigerant seal system. Any oily or blackened spots will indicate that eventually over a period of time there has been a refrigerant leakage from that joint, because along with the refrigerant, compressor oil will also leak out, and that trace of compressor oil will give us a clue that there was a leakage from this place. Every joint, every flare joint, every brace joint, all these joints have to be checked for any traces of oil or blackening. Then we charge the nitrogen for leak test through the same suction line. This is the 3 holes and the 2 valve arrangement manifold. In this manifold, the suction line is connected to the blue hose, and through the yellow hose we are connecting it to the nitrogen cylinder, and we are checking the pressure. We have to charge at least 100 psi of oxygen free dry nitrogen inside the seal system, and then we have to check for the leakages and gradually increase the pressure to 300 psi if the leakage is not found at 100 psi. Many leakages have the they have got a kind of a capability to not show themselves at, not reveal themselves at a lower pressure, but then if you increase the pressure, those leakages points or those small pores will open up at higher pressures, and then there would be leakage over there. So initially from 100 psi we would check the leakage, and if we don't get any 100 leakage at 100 psi, we would gradually increase the pressure to 300 psi maximum, and at 300 psi most of the leakage points should have been found from the seal system. How to find the leakages? That is through a soap and bubble method. We wet some soap onto a sponge and then make a lot of bubbles from it, and these bubbles have to be applied on each and every joint, and when there is some kind of a bubbling which is automatically taking place from that joint, that will indicate that the leaking gas is producing more bubbles in that soap. That is the way how we check the leakages from the joints. Alternatively, for more accuracy, you can also use an electronic leak detector which will show even minute traces or minute leakages of halogens very precisely and very accurately. If the leakage is not found, you have to separate the indoor unit, outdoor unit and connecting pipes and carry the leak test individually to the condenser, individually to the evaporator, individually to the connecting pipes, etc. And whenever the leakage is found, we rectify it. If the leakage is from a flared joint, then we have to flare the joint again. If the leakage is from any other part of the pipe, we have to brace and we have to plug that leakage. After the leakage is being plugged, we inject nitrogen inside the system, and at a pressure of 300 psi we would hold it for at least 2 hours just to check whether the pressure is dropping or not. If the pressure of 300 psi is maintained even after 2 hours, then we would say that the seal system is now, it is joint leakage free, and we can use it for charging our refrigerant gas. And if there is a drop in pressure, we have to again check for leaks following the same procedure. Every time we get a leak, we remove the nitrogen from the system, we braze it, and then we again plug the leakages, and then we again charge the nitrogen and check for the leakages. And after that, what we do is we use a 2-stage, at least 5 CFM, a good quality of a vacuum pump, and then we evacuate the air from the system for at least 1 hour. But then the timing of evacuation is not the criteria. What is the criteria is the evacuation has to be done to the system till the pressure inside the system it reaches at least below 1000 microns or 750 microns, when where this is the vacuum pressure at which we ensure that the entire moisture from the seal system has been effectively removed from it. Always use a micron gauge to check the vacuum in the system. At least it should be below 1000 micron, and if the vacuum has reached below 1000 micron, that means the seal system has been properly repaired and all the water droplets, all the moisture from inside the seal system has been removed. The same connection which we had previously seen, the blue line is connected to the suction line, the yellow line is now connected to the refrigerant pot or the refrigerant cylinder, and the red line is connected to the vacuum pump through a micron gauge. The refrigerant valve has to be closed. Then we have to open the valve A and B of the manifold gauge so that the entire system can be evacuated by the vacuum pump. We start the vacuum pump and check the reading on the micro gauge till the reading comes down to close to 1000 microns or lesser than that. When the reading comes to 1000 microns or lesser, close valve A and B. Now, after that, we stop the vacuum pump, and now the evacuation of the seal system is complete. Now it is time to charge the refrigerant as per the weight of the refrigerant, which is mentioned on the label on the outdoor unit or the indoor unit. Charging the system, press the tare button on the weighing scale so that we reset the weight to 0, and then open the valve of the refrigerant can very slowly. Don't open it very fast so that it is uncontrollable. We have to control the weight of the refrigerant up to a maximum of plus or minus 10 grams. Keep the valve B closed, valve A will be open, and now the refrigerant is charged inside the vacuum system by weight. We will constantly check the weight of the total weight of the refrigerant which is charged into the system. Because of the vacuum, the refrigerant will be automatically pulled into the system. We don't have to do anything to push it into the system. This is how the refrigerant passes into the system. If one can is empty and we still have to fill the refrigerant, what we have to do is we have to close the valve and then we have to remove the can and we have to fit another can. Now for the performance test. Once the refrigerant is charged, the performance test like the ampere reading of the compressor, the temperature achieved at the grill, and the suction pressure at the suction line will tell us how effectively we have done the gas charging. The operation pressure will be as per this chart, the same chart which we have shown previously. Checking the temperature at the grill, keep the digital temperature meter at a distance of at least 2 inches away from the grill and check the outlet temperature from the grill. It should be somewhere around 12 degrees centigrade after 15 to 20 minutes of running of the air conditioners, and it will come to 10 to 12 degrees centigrade after 20 to 30 minutes of running of the air conditioner. Ampere checking, when the compressor is on, we have to check the ampere or the current that the compressor is drawing through the ampere meter. In the ampere meter, we have to clamp it only on one wire, either the phase wire or the neutral wire, and we have to check it. We should not insert both the wires inside the ampere meter clamp. Now the next possible defect is the improper insulation of the copper pipe. The copper pipes which are connecting the indoor and the outdoor units, one of the copper pipe will be colder than the other, and this copper pipe will always have a tendency to attract moisture on its outer surface, and this moisture can condense into water and it can trickle down the copper pipe, and there is a chance that it will create a water puddle or a water mess or a water droplets in and around the indoor or the outdoor units. We have to physically check the insulation of the copper pipe if the outdoor is installed on the roof, because the water droplets can trace the copper pipe and it can come into the indoor unit also. If any cut in the insulation is found, we have to again re-insulate with the proper foam pipe or the foam insulation, which we usually do for the copper pipes connecting the indoor and the outdoor unit. We have to clamp it with wire tie or cable tie or some other clamping method so that they do not get loosened up. Also, where the distribution of refrigerant happens in the indoor unit, the bunch of copper pipes, they can tend to have condensation of water on them because they are directly exposed to the return air. So we have to check the accumulator of water on these distribution pipes, and if it is a problem over there of condensation, then we can have some additional foam insulation which can be wound on top of those copper pipes to avoid condensation of the pipes, water condensation on the pipes, which trickle down the indoor unit and it can cause a mess. Just like this, we have introduced an additional small piece of insulation sleeve and we tighten it with a clip to avoid the entry of air from that place. Blockage of drain tray. The water dripping continuously from any one place of the indoor unit clearly indicates that the drain tray is completely or partially blocked and it is not capable of draining off the water at the rate at which it is formed inside the indoor unit. There is a possibility of the drain tray blockage, and also there could be some dust or some kind of a sludge on the drain tray which is helping the water to become stagnant or not allowing it to flow. If it is not following its designed path, then water will follow some other path, some other easier path. That path could be through the grill, through the blower outlet, and it can be from also the impeller housing of the air conditioner. In this case, what we have to do is we have to open the drain tray and clean it with soap solution, and then we have to refit it. In extreme cases, when after doing all the other rectification process that were explained in the previous slides, if we are not getting any good results, then what we have to do is, in extreme cases, we have to take a plastic folder, that is a piece of rigid plastic, to the length of the indoor unit coil and at least 2 inches height, and we have to place it as shown at the inner side of the rear part of the indoor unit coil, and then we have to secure it with some wire clamps or clips, and effectively what we are doing is we are covering the first two rear side coils from the bottom from coming in direct contact with the air. So this effectively helps to avoid water accumulation in those places and avoid water from being pulled from these places directly by the blower, and then that water trickles down from the blower housing inside and into the room through the outlet grill. So this is a process of blocking the last two coils. This can be done with a minimum amount of skill, but then you have to know where to exactly place that plastic pipe. That is why this diagram is shown. If the insulation of the drain tray is damaged or it has got some cracks in it, then what happens is the lower temperature of the drain tray is passed down to the other plastic parts, the external plastic parts of the air conditioner, and these plastic parts become cold. And once they are colder than the surroundings, it is very easy for the humidity of the surrounding air to come and condense at that particular point, at that particular cold point, and that condensed water can form big droplets and eventually they can fall from that place. If it is falling slowly from some random place which is having some kind of a sweating on it and it is colder than the other plastic parts of the indoor unit, you can be sure that there is an insulation crack behind this plastic part. The repairing for this is to paste a 3 mm thick layer of insulation tape on that cracked insulation part, and then we can avoid the cooling of the external plastic parts of the air conditioner housing. Cracks or defects in the drain tray, the rear drain tray, if there are cracks, if there are any kind of plastic defects, if there are any plastic flashes through which the water droplets can hold on to it and it can trickle down, then we have to check for such defects in plastic. And if there are some cracks, then we have to replace that entire plastic part. We have to replace the rear panel in such cases if it is cracked, if the drain tray is cracked. And sometimes due to rat bite, the drain pipe develops such kind of a damage from where the water trickles down. So we have to change the drain pipe. For poor pumping of the compressor, if the compressor is not pumping properly or if there is any mechanical defect in the compressor, sometimes in rare cases such kind of an ice formation is found on the indoor unit, and this ice will immediately melt and it will form droplets. These droplets are more than the drain can handle and they can fall from all places and they will create a mess of water dripping from any random place. There is no fixed place from where water can fall in such kind of a condition. In such cases, what we have to do is we have to follow the same procedure of compressor, changing the compressor and gas charging. The same procedure which we have shown before, checking the suction pressure. So these are the various kinds of repair process or rectification processes that you can do if you find water leakages or water dripping or water sweating on the indoor unit of the air conditioner. I hope you have found these slides useful and the explanation and the way of rectification also. So whenever you find such kind of a problem, so now you know what to do. We will come back with more such cases of defects and problem solving. Till then, thank you and goodbye.